Did you choose to do this with substitution or elimination?
I did both.
Tried both.
Is that okay?
That's fine,
Is that
yeah.
illegal?
I would, looking at the way, okay guys, looking at the way those equations are written, I think elimination would be easier because I don't really see a good place where I could solve for x or solve for y. And they're lined up nicely. It's just a matter of having to get one to turn into the other. And this is one of those ones, this is kind of the hardest type of problem you could see with elimination because you don't have any numbers that are going to cancel out nicely. You're going to have to change both sets of numbers to get this to work. That's okay, it's really not that hard to change, but it's sort of the most changes you'll have to make in one of these problems. So what do you feel like? You want to get rid of x's or y's?
X.
Okay, x's it is. So looking at my x's, there wasn't a right answer to that, by the way. We could have gotten rid of y's just as easily. If I'm looking at 2 and 7, what could I turn them both into?
14.
Okay, but I want one of them to be... Okay, I need one positive and one negative. All right, so I'm going to turn them both into 14, but I want one positive, one negative. So on the top, I'm going to multiply by... 7. Now on the bottom, I'm going to multiply by... Okay, I heard someone say negative 2. Why am I multiplying by negative 2?
Because that's a negative.
Okay, I want to get... If I multiply by 7 up here, that's going to give me a negative 14. So I want this to be a positive 14. So the negative 2 and negative 7 will make positive 14. Okay, so when I multiply the top by 7, and remember I'm multiplying everything, so I'm going to get negative 14x plus 42y equals 42. No one have any trouble with what I've done so far? No? You trust me? All right. Negative 2 times negative 7 is positive 14x. Negative 2 times 8 is negative 16y. And negative 2 times negative 5 is positive 10. Okay. So multiplied the whole top equation by 7, whole bottom equation by negative 2. And look at that. Now I have a negative 14 and a positive 14. That's convenient. All right. What's going to happen now? Those two are going to cancel, right? And now I'm just adding these and these together. So 42 plus negative 16 is, I believe, 26. Am I right? Yeah, 26. And 42 plus 10 is 52. Divide by 26. And y is equal to... y is equal to 2. 52 divided by 26. Okay, 26 times 2 is 52. Okay, what do you want to do with that?
Plug it in.
All right, in which one? You pick.
Top.
Okay, the very top one, this one up here?
Yeah.
I could plug it into any of these 4, but we'll go with the top. And remember, I'm plugging it in for y, so this is now going to say negative 2x plus 6 times 2 equals 6. So negative 2x plus 12 equals 6. Subtract 12. I end up with negative 2x equals negative 6. Divide by negative 2. And x equals 3. So then my final coordinate would be 3, 2. Someone who attempted this problem and was having trouble with it, where did you mess up? What did you do differently from what I did?
Cancel out the y's.
Okay, you canceled out the y's instead, which technically would still work. What did you turn them both into?
24.
Okay, that should work fine. Were you able to get that answer out of it? No? I wonder what.
I couldn't find what I did wrong.
Okay. Let's try that real quick.
Maybe because I was just tired.
Something else to write in. No, that's okay. So we would have multiplied the top by 4 instead. Now I'm trying it Kyle's way. So by 4 here and by maybe negative 3 here. Is that what you did, Kyle?
Yep.
Okay, so that would give us negative 8x plus 24y equals 24. And this would be positive 21x. Negative 3 times 8 is negative 24y. And negative 3 times negative 5 is positive 15. So these would cancel this time. Negative 8 plus 21 is 13.
I should have it wrong.
Did you find it?
Yeah, I didn't put negative 8 instead of
Okay.
put 8.
Okay, yeah, if that was just an 8, that would mess it up. And then this would be 39. So when you divide, you would get x equals 3, just like we did back here. And then when you plug that back in, you should find y equals 2. Okay. Anybody else see something they did wrong? Caitlin?
Oh, wait.
Or-
I have a different problem.
Sure, go ahead.
14.
14. Okay, and then I know there were some other ones down here that we wanted to get to too, so we'll come back. 14. Okay. 14 again, I would probably use, well, substitution would be okay on this one too, because that bottom equation wouldn't be too bad to get y by itself. What do you feel like? Substitution or elimination? Substitution? Let's give it a shot. So if I did substitution on this one, I would probably get this y by itself, which means that I would add 5x to each side, and I would get y equals 5x plus 13. Okay? And then I would take that y, which is 5x plus 13, plug it in for y up here. So that's going to give me negative 3x plus 3, and then in parentheses, 5x plus 13 for y equals 3. Distribute the 3. So negative 3x plus 15x plus 39 equals 3. You can combine these two, so that's going to make 12x plus 39 equals 3. Okay, subtract the 39. I end up with 12x equals negative 36. Divide by 12. And x is equal to negative 3. Following so far? Any questions on any of that? Okay. I'm going to take this x is equal to negative 3 and put it right back in up here. So y equals 5 times negative 3 plus 13. That's going to be negative 15 plus 13, which is negative 2. Is that, yeah, negative 15 plus 13, negative 2. And so final coordinate here would be negative 3, comma, negative 2. This worksheet sure loves their 3's and 2's. Lots of 3's and 2's on this assignment. Okay, Caitlin, that make sense?
Yeah.
Okay. What else did we need down here? Did I hear 19, maybe? 19? Okay, 19. Again, because I don't have any lonely variables, I don't have any variables that look like they're ready to be solved for, I would probably go through this with elimination. Okay? And again, I don't have anything nice for elimination. I don't have like, you know, I can multiply this by 2 and turn it into a 5 or anything like that. So I just have to pick. What do you want to get rid of, x's or y's? Sure, x's. Okay, so the 5 and the 2. What could I turn them both into? 10. And I just want to make sure one of them is going to come out negative. So if I want to turn that 5 into a 10, I'm going to multiply by 2. If I want to change this 2 into a 10, I'm going to multiply by 5. Okay. Am I all set for my negatives? Like, when I multiply, am I going to end up with one negative and one positive 10? Yeah, because this one's going to come out negative, this one's going to come out positive, so I'm good. So let's see, on the top I would get negative 10x minus 16y equals 34. On the bottom, 5 times 2 is 10x. 5 times negative 7 is negative 35y. And 5 times negative 17 85, negative 85. Is that right? Someone double check that and stop me if that's wrong. Okay. Now look, I've got negative 10 and positive 10, which is what I needed to have happen. That's the whole reason I did all of that. So if you do this step, and when you rewrite your equations, you don't have something to cancel out, you messed up somewhere. Okay? Add those together, those cancel. Negative 16 plus negative 35 is going to be negative 51. I believe. 45, 45, 51. Yeah, negative 51. 34 plus negative 85, also negative 51. Pretty sure. Divide by negative 51, that worked out easily. So what do I get for y? Do I get 1 or 0? 1, yes. When you divide a number by itself, you get 1. So y is equal to 1. Where do you want to plug it back in? Top one? Okay. So that would go in for y right here. So I'm going to have negative 5x minus 8 times 1, which is just 8, equals 17. Let's rewrite it as. Add 8. Negative 5x equals 25. Divide. X equals negative 5. So final coordinate would be negative 5, comma 1. Good? Pick one more. If there's one more. Yep, Laura? Number 2? Sure. Okay, looking at number 2, I would probably go with substitution. What about that problem makes me think substitution?
The y equals.
Yeah, I've already got y by itself, which is what I like to have for substitution. So if that's already done for you, that's kind of a no-brainer. And especially since I would have to rearrange this equation to get it to line up with that one in order to make elimination work. So let's just go with the easier one based on how it's set up to begin with. So if I have y equals x minus 1, that means I'm going to take that x minus 1 and put it in place of y up here. Long morning already. So this is going to look like this. 2x minus 3, parentheses x minus 1, because I'm putting x minus 1 in place of y, equals negative 1. Now, this is the kind of problem with substitution that people make the mistakes on the most often. Okay? I see a lot of people when they have this, when they distribute that 3, they lose that negative sign. Or sometimes they get it like on the first one. So, for example, I'll see a lot of this. 2x, and then they'll say, well, 3 times x is 3x, so it's going to be minus 3x. 3 times negative 1 is negative 3, so that's going to be a negative 3. That right there is a very tiny mistake that's going to make your whole problem wrong. That's a negative 3. And I would just get it through your head that I know you're used to reading that as minus 3. It is minus 3, but minus and negatives are the same thing, the same concept. So this is really a negative 3 being multiplied by a negative 1. So what's that going to give you? Positive 3. Negative 3, negative 1 is going to make positive 3. Okay. Right here then, I'm going to combine 2x minus 3x and get negative 1x plus 3 equals negative 1. Subtract 3. And I end up with negative 1x equals negative 4. Divide by that negative 1. And I get x equal to positive 4. Questions on that? And then when I do it with substitution, I usually find it easiest to just plug right back into the one that's already solved for y. So this would be y equals 4 minus 1, which means y equals 3. And so then my coordinate, 4, 3. Okay. Doing well?